Hi everyone, so in this video we'll try to discuss chapter 4.5. Okay, so last time we already discussed this one, 4.1, 2, 3, 4. Right, we stopped over here in previous video. So today we'll discuss 4.5. 4.5 is about force between two parallel current carrying conductor. So previously we learned that if you have a current carrying conductor sitting inside a magnetic field, then you will experience a force. Okay, so now what will happen if you have two parallel current carrying conductor? So in this example, I try to show you first on how to calculate the magnitude of the force itself, and then I will try to show you how to determine the direction, and then afterwards we try to do some question. Okay, if you can see over here, there's two current carrying conductor. The two currents are going in the same direction. So same direction means as long as it's in the same direction, it's valid lah. So like in this example, both are going up. Okay, if both are going down, then it means it's still in the same direction. Okay, if you want to calculate the force acting on this second conductor, this is my first conductor, this is my second conductor. If I want to calculate the force, that means I have to find the magnetic field over here. So that would be the first step. Okay, so to determine the magnetic field on the second wire or second conductor, you have to use right hand grip rule, and then you have to apply it for this particular wire, right? Because this is the wire that will produce the magnetic field over there, right? So what you're gonna do is that you have to put your thumb in this direction. So literally this is your thumb, right? And then this would be your fingers, the four fingers, and you can see that the four fingers is actually pointing into the page. So that means over here, over this region, okay, you have a magnetic field that will produced by the first current carrying conductor, and the direction of the magnetic field will be into the page. So this one is B1 and the direction will be into the page. Okay, the reason why this one is B1 is because this magnetic field is being produced by the first current carrying conductor, by I1 lah. And then if you guys still remember, to calculate force, right, for current carrying conductor, you can use the formula of BIL sine theta. Okay, so if I want to calculate force on 2 by 1, I have to use the current that is going to that is inside the second conductor. Okay, but the magnetic field itself, it will be from the first conductor. So that one is B1. Okay, so to calculate B1, I can use mu naught I over 2 pi r. Okay, but since the distance between these two conductors, let's say if I put this one as D, this is the distance, then my R becomes D. So instead of R, I can write it as D. This is my I1, and the D would be the distance between the two conductors. And I can substitute the whole thing inside here, right? So that you have an equation which is equals to mu naught I1 over 2 pi D multiplied by I2 L sine theta. Okay, and since the theta would be 90 degrees, that one is equals to 1. So this one is 1, so you can ignore that part. So now you're left with an equation of F21. And since if you want to calculate force acting on the first wire, basically have the same formulas, just that you flip between I1 and I2, so the magnitude will be the same. So you have F12, which is equals to F21, and that equals to mu naught I1 I2 L. I mean, if you want to use the symbol that you use in the formula, maybe it would be L capital, and then over 2 pi d. Okay, L here represent the length of the wire itself. So this is how you calculate the force acting on two parallel wire. So this is the formula. Okay, to determine the directions of the force, let's say on wire 1 or on wire 2, you can use the right hand slap rule that I showed you previously. Okay, so to determine magnetic field, you use right hand grip rule. After that, okay, you can apply right hand slap rule ataupun palm rule. Okay, in this example, your thumb will be pointing upwards. Okay, because it follows the direction of current, and the four fingers will be pointing into the page. Okay, similar to this one lah, into the page. And since your palm is over there, and then it will be going in that direction because this one is a current, same with the positive charge. So in this case, direction of the force acting on this wire is to the left. Okay, and if you try to repeat the same thing, okay, where you try to determine the direction of magnetic field over here, which is going out of the page, okay, using right hand grip rule. Right, basically you put your thumb over here and your fingers will be pointing out over there. So over here, my B is going out of the page, and this B is actually due to second current carrying conductor. So I put this one as B2 out of the page, and I can apply right hand palm rule or slap rule. Your thumb is pointing in this direction, and then all your fingers is pointing out, So if you use a positive, so it will be in that direction. Okay, so if you want to answer only for this part, the force acting here will be to the right. Okay, so you can see that the force actually, one is pointing to the left, another one is pointing to the right. F on 1 by 2, F on 2 by 1. So the magnitude will be the same, and the direction actually will be attractive force. Okay, so as long as you have two current carrying conductor parallel and in the same direction, the current flows in the same direction, you have attractive force. Okay, but if the currents are in opposite direction, it will be in opposite direction or repulsive force. Okay, for case number 2, you can try to do it yourself. Okay, determine the direction of magnetic field, and then after that you use palm rule to determine the direction of the force and check whether this one stands or not, this one correct or not. I just complete this one. So this would be I1, I2, I1, I2, and the direction over here would be to the right. This one is to the left. So this would be F on 2 by 1, F on 1 by 2. On the other hand, this one will be attractive force, F on 2 by 1, F on 1 by 2. Okay, so you can try to do it every time, like you determine the direction of magnetic field, and then after that you determine the direction of force, or maybe you can try to memorize it as well, to save some time. Okay, let's try to look at tutorial question. This is question number 13. Okay, they give you a diagram. It says that it consists of long straight conductor over here, and then carrying a current of 6 ampere, and a rectangular frame PQRS is suspended with PS 3 cm from X. The sides of PQ and QR are 4 cm and 11 cm respectively. So everything are in the diagrams. And current 3 ampere flows in the rectangular coil as indicated. So the flows of the current inside there, I just follow the direction of the arrow over there, will be in that direction. Right. And then the conductor X, okay, everything are in the same planes. The first question, they want to calculate the force on wire PS. Okay, so if I want to determine the force acting on the PS, okay, I can focus with these two particular component. I mean, two particular parts. The rest I can ignore because the remaining one, like some student might get confused. It says that why this one does not produce a force over here, and the reason is because all of these are in the same body. I mean, it is basically the same wire. So you can see previously, current on the same source, it does not produce magnetic field on top of its own self. Like this one, it does not produce magnetic field over here, okay, because this is basically the same body. I hope you guys can understand. If you don't, you can ask me later. Okay, so this would be the directions if I just focus on the two part, okay, XY and PS. And if I want to solve this one, I can straight away use the formula. F equals to mu naught I1 I2 L over 2 pi D, right? Okay, so if I want to use this formula, my I1 represent I corresponds to XY. My I2 corresponds to I from the PS, okay? And the length needs to be the length of the wire itself, the one that we want to find the force. So it will be the length of PS, which is equals to 11 centimeter. Okay, straight away I change to meter. And then I also need to have the values for D, which is 3 centimeter. The one becomes 0.03 meter. Okay, so if I substitute all the values inside here, then I will have F equals to 4 pi times 10 negative 7. I1 is 6, I2 is 3, length 0.11, okay, and then over 2 pi multiplied by 0.03. Okay, if you press your calculator, you should get F equals to 1.32 times 10 negative 5 Newton. Okay, because the force is a vector quantity, so you have to determine the direction as well, even if the question doesn't ask. So here you want to find the force acting over here, determine whether it's going to the right or to the left. Okay, you can straight away memorize like previously. Not over here, if you have in the opposite direction, it is a repulsive force. This one is in opposite direction, so produce repulsive force. So straight away you know that this one is to the right. I mean, this one is force on PS by XY. Maybe I can put 2-1 over there. So the direction will be to the right. But since this is the first time, this is the first example, maybe I can try to show you again on how to determine the direction. So you put your thumb over here, pointing downwards, okay, so that you can get the magnetic field on the right hand side on the wire PS itself. So you can see that the direction of your curl, your fingers will be pointing outwards. Right. You use right hand, put your thumb over here, and then you can see that over in this region the magnetic field is going out of the page. And then you can use the right hand palm rule. Okay, put your thumb in this direction upwards, so your thumb will be in that direction. Okay, and then all your fingers will be pointing out of the page, because this one follows the direction of magnetic field, positive, and will be in that direction, okay, to the right. Okay, and then the next part is that they ask you to find the force on the wire QR. So now I just want to focus between X, this one is X1, right? Wire X only, okay. So maybe I have to change everything, or maybe I just add this one as XY. Okay, so now I want to focus on this part, XY and QR. So this one is going downwards over there. Okay, keep that in mind. I just redraw this part. So copy everything, put it over here. Okay, so maybe this one is a bit further away, and this one is going downwards. Okay, this is a 6 amp, then that one stay 3 ampere. Okay, the length is still 0.11, just that the distance now is increasing. So previously you have 3 centimeter, now the distance between the two wires will be 7 centimeter. You have to add these two. So now D is equals to 7 centimeter, which is equivalent to 0.07 meter. Okay, these two wires in the same direction, now it will produce, okay, I go back again just to show you, same direction, whether it's going upwards or going downwards, it will be attractive force. So the force in this particular segment will be pointing to the left. Okay, so the formula that I want to use, F on 2 by 1, will be mu naught I 1 I 2 L over 2 pi D. Okay, again 4 pi times 10 negative 7. I1 would be 6, I2 would be 3, the length is 0.11, so everything else are the same except the distance, which is 0.07 meter. So if you calculate this one, you should get 0.566 times 10 negative 5 Newton. Okay, and the direction will be pointing to the left. Okay, then the last question, they ask you to find the resultant force on PQRS and determine its direction. Okay, so you have two forces acting over here. So you can see that this one is to the right, and then the second one is to the left. Okay, so if I want to draw it over here, this one is to the right and this one is to the left. So I just label this one F on PS and this one as F on QR. So if I want to find the net force, okay, I can do vector sum like FPS minus FQR, and then you get the final answer. Okay, notice that over here is actually you have a force as well. Okay, but these two forces will be cancelling out each other. Okay, they cancel out each other simply because if you try to do the or the force direction, you determine the direction of the force, you can see that, I just try it, this one is going downwards and this one will be going upwards. You can check again. Okay, so because this one you have the same magnitude because the distance will be the same, always the same. Over there is the same with that one, over there will be the same with that one. So all this force over here will be cancelling out each other. Okay, so the only one that you want to focus or calculate is this part. Okay, so the F net will be F on QR minus PS. Sorry, PS minus QR, because I'm gonna do right minus left. PS minus QR. Okay, so you will have 1.32 minus 0.566 times 10 negative 5. So this one you should get 7.54. I'll just double check. (0.754) times 10 negative 6. Okay, because this is positive, because we do positive, sorry, to right minus left, the answer is positive, so this one is to the right. Okay, that's it for this video. Thank you.